What were Archimedes' greatest mathematical contributions? Imagine a time when numbers and shapes were just beginning to be understood, and one brilliant mind changed everything. That mind was Archimedes. His work in mathematics helped shape how we understand the world today. Archimedes created a method called the method of exhaustion. It was a way to find areas and volumes by breaking shapes into tiny pieces. This technique was so advanced it predicted what would later become integral calculus. He used it to find the area of curved shapes like parabolic segments, which was impossible before. His idea involved adding up an infinite series of small shapes to get a close estimate. This showed he understood limits and infinite processes long before they were formalized. He also made a huge leap in understanding circles. Archimedes calculated the value of pi, which is the ratio of a circle's circumference to its diameter, with remarkable precision. He inscribed and circumscribed polygons around circles and measured their perimeters. Using polygons with many sides, he estimated pi to be between 3 and 1/7 and 3 and 10/71. That is about 3.1429 and 3.1408, respectively. This was a major step in connecting geometry to numerical values. Archimedes also thought big when it came to numbers. In his famous work, The Sand Reckoner, he tried to count the grains of sand that could fill the universe. He developed a system to express very large numbers, far beyond the Greek numeral system. This was an early attempt to understand and work with enormous quantities, pushing the limits of how numbers could be used and understood. In geometry, Archimedes made important discoveries about three-dimensional shapes. He proved that the volume of a sphere is 2/3 that of the smallest cylinder that can contain it. He also found formulas for the surface area and volume of spheres, cones, and paraboloids. These results helped mathematicians understand the relationships between shapes and their sizes. His work in physics and fluid mechanics is equally impressive. Archimedes discovered the principle that explains why objects float. He showed that a body submerged in a fluid experiences an upward force equal to the weight of the displaced fluid. This principle is fundamental in understanding buoyancy and has many practical uses today. Archimedes also studied how objects balance. He found ways to calculate the center of gravity for different shapes, which is key in designing stable structures. He created laws for levers and pulleys, explaining how to multiply force using simple machines. This work laid the foundation for engineering and mechanics. Finally, he used the idea of infinitesimal, tiny, infinitely small quantities to find areas and volumes. He described infinite series like geometric progressions, which are still used in mathematics today. His work bridged the gap between geometry and algebra, setting the stage for future discoveries. All these contributions show how Archimedes helped move mathematics from basic counting and shapes into a more precise and abstract science. His ideas about limits, infinite series, and geometric ratios are part of the reason numbers and shapes became so powerful in understanding our world. His work influenced not just mathematics but also engineering, physics, and astronomy, making him one of the most important figures in the history of ancient mathematics.